Today we're going to be looking at solving equations by factoring. Something we've already done a little bit of, but now we're just going to get a little more in depth and see some different types. So let's get started. All right, so the first type of problem, actually before we even start, it's important to think about the typical equation that you would be factoring, because these might look a little bit different, where we've got a coefficient with an x squared term, then another coefficient with an x term, and then a final constant, also a coefficient if you think about the term behind it of x to the 0, which x to the 0 turns into 1, if you remember those exponent laws. So we got 3 coefficients and 2 x terms, and they're going to stay separate because they don't have like terms, because they're not alike, because you can't combine 2 terms with different exponents or different variables. So that's important to remember as we look through things. For instance, when you look at number 1, there's no constant, so it's important to remember, okay, well, since there's no constant, we might be solving it a little bit differently. Actually makes it, anything that's missing makes it a little bit easier. So let's just look at this together. We're going to say, okay, well, what can we do? We can factor, right? Factoring takes the form of like reverse foiling, but also sometimes it's just the simple factoring, like the reverse distributive property. So if you remember, the distributive property was whenever you got some number and then parentheses and like x plus 2, it doesn't matter, you distribute that number, right? We can do the same thing in reverse, where we take a bunch of stuff and we factor it out instead of in to those parentheses. So if I were going to put parentheses around here, I'd say, what can I take out? What do the 2 things have in common? Well, I definitely see an x that they have in common. And then I think about the greatest common factor, or what terms does 18 and 24 have in common? And looking at it, 6-ish, maybe. And that's just a guess that my brain makes. It might be higher, it might be lower, but we'll see as we go. So I'm going to pull out 6x. I'm going to draw those same distributive arrows, but going in reverse. So if I pull a 6 out of 24, I'm left with 4. And if I pull an x out of x squared, I'm left with x. Minus sign, if I pull a 6 out of 18, I'm left with 3. And if I pull an x out of x, I'm left with nothing, no x's. Well, there we go. So we're looking pretty good. 4 and 3 don't have anything in common. They can't combine, so that was a good guess. 6 was a good greatest common factor. If it wasn't a good greatest common factor, there'd be another constant term you could pull out. But since 4 and 3 are mutually prime, we're good to go. So now we've got 6x and we've got 4x minus 3, and they equal 0. So here's like a kind of rule or a property to think about, is that capital A and capital B equals 0. That means that either A equals 0 or B equals 0 or both. But there's no number you can possibly think of where those 2 numbers multiplied will equal 0, where one of those isn't 0, right? 1 times 1, 1 times infinity, 1 times 6, there's 2 times 4. Like, there's no numbers, even negatives, that give you 0 without one of those being 0. So we can pull the property 6x equals 0, or 4x minus 3 equals 0. One of those 2 has to be true, or both of them have to be true. And then we can just solve each one. So if we solve the blue one, we're left with x equals 0. And if we solve the black equation, we're left with x equals 3 over 4. Right? Another way you can write those is you can draw a set and say 0, 3/4. That is the set of solutions for this equation. Cool? All right. Number 2 is pretty similar. Number 3, we'll do 3 and 4, so you can kind of see an example of one of each. And I'm giving you some free problems here. Number 3 is foiling, like when you did first, outer, inner, last, or the box method, but in reverse, right? So what we do is we look at our last term, our c, our constant term, and we say, what numbers multiply to get me that c? 7 and 1, 1 and 7, same thing. -1, -7, I think that's it. Okay, and then we ask ourselves, if we add those up, which ones give us our b value, or our middle term, which in this case is a positive 8. So which 2 of those terms give us positive 8? Not the third. And those 2 are the same, so it doesn't matter. You pick either. Boop, boop. All right. So then we take those terms and we write our normal FOIL, our normal binomial multiplication, where we've got x plus 7 times x plus 1. That's where we just pulled those blue terms down and wrote them right there with their signs. If it were negative, if it were a -7, we would have written x minus 7. It's important to note that if you want to check, because you don't know if you did it right, go ahead and FOIL the first, outer, inner, last, or box method, if that's better for you. And then we set them equal to 0 because we still have that equals 0. Well, now we can solve these with the same properties of a equals 0 and b equals 0. And if we look at those, we're going to be left with x equals -7 and x equals -1, or the set of -7 comma -1. All right, but sometimes you've got an A coefficient. If we look back up to the top real quick, see that A coefficient right there? Sometimes we've got a coefficient in front of the x squared. And then there's a couple different ways to do this, but my favorite way to teach is this thing called slide and divide, where you're going to slide that 3 to the end, and that slide takes the form of multiplication. So we'll be left with x squared minus 7x plus 6 equals 0. Now we can't just do that willy-nilly. It's going to come back, and we're going to fix it. We're going to fix what we did. But for now, we're just sliding it over with multiplication. I'll write multiplication so you can tell. Multiplication. All right? So we slid it over, and now we're going to factor it normal style like we just showed you how to do. So if I'm going to factor that, I'm going to be left with x minus 6, x minus 1 equals 0. Okay? But we can't keep going. We got to stop. We did the slide. Now we have to divide. So I guess here, I'll write the name. Slide and divide. So this is the slide where we multiply the first term, the a by the c. Now we'll do the divide. The divide, we're going to take that same term, which was 3. So we multiplied by 3. And we're going to divide by 3. So then we'll be left with x minus 2, x minus 1/3. Great. This is good because it gives us an example of when you're left with a division that you need to take care of. So the x minus 2 is good. Good to go. Happy. Leave it. We're good. We're happy with it. It looks normal. But that x minus 1/3 is a little tricky because if we multiply x times x, if you're foiling, and the f in FOIL stands for first, right? That's the first terms. If you multiply x times x, you get x squared, right? Well, our first term of this thing isn't x squared. It's 3x squared. So that's where the slide comes back into play. So we slid, we divide, and that, technically maybe it should be called slide and divide and slide, because now we're going to slide that 3 back to the front. Just like that. We're not doing any maths. We're just sliding that 3 back to the front. So we're left with x minus 2, 3x minus 1 equals 0. And then you can solve it just like normal like we did last time. So you'll be left with x equals 2 and x equals 1/3. Also known as the set of 1/3 and 2. Cool? Slide and divide. And I like that. It is kind of like slide, divide, then slide again. Slide, divide, and then slide again when if you're left with a fraction. But if you weren't left with a fraction, you wouldn't have to do that. And it doesn't affect your solution. It only affects the actual term itself. So the solution's the same whether you do that last slide or not, right? If you look right there, I'll show you what I'm talking about. If you look right there at that green term and you solve it for 0, you're going to get 1/3, which was our answer. Well, if you look right here at this green term and you solve it for 0, you're going to get 1/3. But the reason that we had to do that last slide is because if you were to FOIL and get the correct factorization or the correct terms, this step right here doesn't give you your original equation. We need to do that slide so we get the correct first term. Okay, that should be everything you need to know. I'm going to scroll through real quick and look. We need to do some distribution here before working. Just a little note. I need to do some FOIL here. If you don't remember how to FOIL, come to office hours. We'll be happy to help. Looks like we got a factoring by grouping. And yeah, no. Let's see. Let's look at number 9 and give you a little head start on it. So number 9, it's a little different than the rest, right? It has a x cubed, which is a little tougher because now we've got to do an extra step of factoring. So before we get started, let's see what happens if we move everything over to one side. So you'll be left with 3x cubed plus 2x squared minus 75x minus 50. All we did is move stuff over. Should be happy with that. And then what I'm going to do is I'm going to do my normal factoring, but I'm going to do it twice. I'm going to do it with the first terms, and then I'm going to do it with the second terms. All right? So that normal factor out, let's see what happens if we factor out a 3. No, there's not a 3 in common. There's nothing in common. It would just be x squared gets pulled out. We pulled an x squared out, so we're left with 3x plus 2. And then I'm going to put a plus sign here so we don't forget they're being added, not multiplied. And then what looks common? Negative 25 probably. So if I pull a negative 25 out, I'm left with 3x plus 2. This is great, a great example, because those two terms are the same. So now what we're allowed to do is do x squared minus 25. That's us pulling these blue underlined terms right there, times 3x plus 2 equals 0. And then I'll let you solve that like we just did the rest of the problems. All right. We can look at one. We will look at one problem with the x's on the bottom, or a rational equation, and see what happens. So here we've got a rational equation with x plus 1 on the bottom, right? 1 second. Rational equation with x plus 1 on the bottom. So what we're going to do is we're going to take those x plus 1s, and we're just going to make sure we have a common denominator. We need to have a common denominator before we can move forward. So what I'm going to do is I'm going to just multiply by 1, right? You would agree we're allowed to multiply this 3 times 1. So 3 times 1 is 3, so you can just erase it, right? Well, what if I change that 1 to x plus 1 over x plus 1? That's still 1. So 3 times 1 is still 3. It didn't change anything. It just gave us a common denominator. So now we've got 3x over x plus 1 equals 2 minus 3 times x plus 1 all over x plus 1. Awesome. So here's something interesting that we really need to note is that when you're back in 3rd grade, there was one thing your teacher taught you, right? When you're learning addition, subtraction, multiplication, and then when you learn division for the first time, your teacher said you can never divide by 0. So is there a number that gets us our divide by 0? Absolutely. X better not equal negative 1. If x were equal to negative 1, we'd be dividing by 0. That's bad. Okay. So let's see what happens if we just work out some maths, keeping in mind x can't equal negative 1. Multiply both sides by x plus 1. Because you're allowed, what you do to one side, you have to do to the other. And we cancel out our bottom and our top, keeping in mind the condition x can't equal negative 1. That's a note we made at the top. Okay, so now we're left with 3x equals 2 minus 3x minus 3. I went ahead and did my distribution. Now we're going to cancel some stuff out. Subtract 3x from both sides. Ooh, I'm going to add 3x to both sides. That'll help us out easier. Move my x's to the left. Left with 6x equals 2 minus 3 is negative 1. That one cancels. Divide by 6. Divide by 6. We're left with x equals negative 1/6. And this is the part where we're going to go back and we're going to check. Does that contradict our original note or original statement? X can't equal negative 1? No. X equals 1/6. We're good to go. Boop. Also known as the set of 1/6. Cool? All right, that note at the beginning is the most important when you're working with rational equations. Everything else is normal maths. Thanks for watching. Make sure if you have any questions, make sure you come to our office hours Tuesdays and Thursdays from 8 o'clock to 12 o'clock. Dr. Solis will watch y'all from 8 to 10, and I will watch y'all from 10 to 12. Let us know if you have any questions. Hop in those office hours, and we'll see you next week. Thank you.